Okay, today we're going to take a look at habitat management and what features you should really be looking at. Most of this information comes from the Wildlife Habitat Evaluation Handbook, which is part of the 4-H Council. I should also mention that Colorado Parks and Wildlife has created a state wildlife action plan that also addresses some of these same points, and I've used some of their information as well. Okay, so when you're managing habitat, we've said this in class already, but there's always just two goals. What would you assume would be your two goals? And how this screencast needs to work, folks, is that I need you to engage. Hopefully you're watching this in a room by yourself and it doesn't matter too much if you talk out loud, but I would like you to engage and not just let me feed you here this whole time and think about it. What are the two goals of habitat management? Hopefully, you said it was to maintain a quality habitat in areas where it already exists in a natural system. But when quality habitat isn't available, our other goal then would be to improve habitat where it has deteriorated or maybe just where a certain element is lacking. And with this in mind, we also need to think about what species we're managing for. You can't just say habitat is good or habitat is poor. You have to associate that with some objectives. Who are you managing for? What are you managing for? Never ever catch yourself saying, wow, that's really good habitat, because it doesn't make any sense if you're not associating it with what species you're trying to look at. But if we do kind of take a step back for a moment, there are certain elements, requirements that we would want to take a look at. Generally, we've talked about this and you learned it in second grade, right? All animals need food, water, cover, and space. However, each species has its own particular needs, hence why we need to associate it with the species. And those needs are not simple. They're not one for the entire year. It varies with seasons. So when you're looking at a habitat, you can have the best summer habitat, the best winter habitat in the world, but if it doesn't have rearing habitat for young, your population will decline. So it's really important that as a manager, you're not considering just what is there at that moment in time. You need to not only know, but you need to evaluate the needs of the species for an entire year. The second concept is this idea that we're going to manage habitat for a featured species. And in your assignment, your take-home assignment today, that is what you will be doing. The problem with looking at one featured species is that it doesn't consider the needs of everything. And you can't consider the needs of everything. You're going to have trade-offs. When it's beneficial for one thing, it might be detrimental for another. So if you're selecting for one featured species, then you are not selecting for species richness. Remember, species richness is the number of different types of animals in an area. You really can't do both. So you have to choose a management option that is going to target the limiting factors and realize that anything you do will have an impact on other species in that area, for better or for worse. And in the habitat evaluation guide that I'm going to provide for you for each species, pay attention to that. It will say things like, if you're improving habitat for turkey, for example, realize that you may also encourage some unwanted species to be in that area. Or the habitat features that are really important to turkey might not be as important to some other animals, so you're going to be making some trade-offs, especially when you're thinking about managing for one particular species. Okay, if you manage for species richness, on the other hand, you're thinking about what can I do that creates the most good for the broadest amount of species. And it might not be the best habitat for any one species, but it might be better habitat for a variety of species. Again, you have to know what each species actually needs and wants in order to make this happen, even though your goal here is species richness. Much more difficult on a management objective to manage for species richness. Okay, concept 4, plant succession and its effect on wildlife. Hopefully this idea of plant succession is not new to you. We've talked about it already in class, but I cannot emphasize enough the importance of recognizing how animal communities are associated with different several stages of plant succession. So if you think about how a community progresses either after a major disturbance or just from the start, maybe there was not any previous communities there, in which case we would call that primary succession. You're going to go from bare ground to then having some forbs and grasses that are probably annuals, meaning they come up every year from seed. And that will then create the microclimate suitable, the soil that's suitable for more perennial forbs and grasses, and then shrubs, and then you're going to get some trees. Now, what phase in here becomes your climax community is going to be highly dependent upon your climate and your topography. You may end up with a shrubland, and that is its climax community. You may end up with a grassland, and that is its climax community. So realize we don't always get all 6 of these categories of seral stages, but you do need to know which seral stage should your habitat be in for the species that you're trying to target. And I think I just said that. Okay, so looking at a few specific concepts. First is vertical structure or vertical layering. With this, you're looking from ground to top at how many different vertical layers there are in that habitat. So a habitat that has a lot of vertical structure, they're going to have cover essentially from the ground all the way up to the tip tops of the trees. And let's see, I wonder if I can move, nope, I can't move it. It's cut out of your screen, but we have grass at the very bottom, so you're not seeing that. But grass, and then maybe some shrubs, and then maybe some small trees, and then maybe some larger trees. Or maybe it is more of a conifer tree that has branches going all the way down. We tend to think of connectivity in habitat across a horizontal landscape, but we need to remember that vertical structuring is just as important for some species. So concept 5, arrangement and interspersion, which is horizontal layering, and I apologize that that's cut off a little bit too. I can't get this screencast to cover my entire screen, but that should say concept 5, arrangement and interspersion. So here we're saying animals may need several different types of habitat in one area. And so we do need to think about connectivity as they go to and from these different types of habitat. And this is where this idea of edge comes into play. And we've touched on edge so far in this class, but I really want to make sure you understand this concept. The idea of edge is that you have 2 transitions happening, or an area where 2 habitat types meet. So down here on the bottom, this is a really good example of edge. You've got some overhead tree species, you've got some trees and shrubs, you've got tall grass, some forbs. This area right here, you actually have 3 habitat types meeting, and you could even call this little strip along the road a 4th habitat type. In the picture over here to the right, you have a field, maybe with some trees interspersed, different types of vegetation. This one might be more bare ground. You have this riparian corridor, you have a woodland. So you have at least 6 or 7, maybe 8 different habitat types all in this area. This would be an example of a habitat system that has a lot of edge. Here you have a wetland mixed in here with your forest, and different forest types too, deciduous and coniferous. The reason why edge matters is, I should back up. Quality of edge is measured by how gradual the transition is. So right here, this would be really fairly good quality of edge. Instead of it being a stark contrast between the overstory and then the shorter vegetation types, you kind of have this stair-step effect. And so that gradual transition makes it a better quality. Now, what would make this even better quality is if these were even wider, covering a larger area as you transitioned from the bare ground into the forest. There's a couple different types of edge to consider. Inherent edge is just the natural differences in the landscape. That can result from maybe topographic differences like tree line, elevational gradients. Think about our grasslands transitioning into our shrublands of our foothills, and that transitioning into our woodlands or our ponderosa pine forest that's widely spaced, and then that transitioning into our mixed conifer forest as you go up in elevation. So that would be very broad, different ecosystems coming together. And you could think of edge as similar to ecotones, where two ecosystems are transitioning, but edge can also be a much smaller scale. So it may not be a transition into different ecosystems, it could just be a transition into different habitat types. But either way, you can have inherent edge that might be dependent on soil and water, geomorphic changes, things that occurred on the landscape without our interference. And the other type of edge is induced edge. This is caused by some kind of disturbance, either natural or human, generally human. But fire, floods, those are natural disturbances that could have created the edge. Roads, power lines, timber harvesting, grazing, all of which can be induced edge. Usually induced edge is short-lived because it was caused by a disturbance, and the plant communities will succeed and kind of fill that edge in. And I showed this a couple slides back, the idea of high contrast edge or hard edge where there's an abrupt change, or low contrast or soft edge where there is less distinct change, and usually soft edge is more beneficial for wildlife. Then we have this concept called the edge effect. This says that densities of animal species are higher in this transition zone. So remember densities, the number of different types of species and the number of individuals in each of those species being higher. Why would you expect that in an area with edge you would have higher densities of species? Take a few seconds and see if you can answer that question. The idea here is that you have a lot of habitat types merging right there in edge, so there's needs for a wider variety of species. There's been a lot of research done on this. This guy, Sisk et al. In 1997, they were looking at bird species along edge habitat, and they realized that areas that had edge patches that had the similar types of habitat, similar elements as the matrix surrounding that edge, had a higher species diversity within the edge than the species diversity in the broader landscape, even though all the species that were present in the edge were present in the broader landscape, but not in the same densities. So we're seeing that there might not be different species overall in those edge, but the density and the diversity of species is higher. And we have some examples. Why might edge benefit some species? We're kind of talking about that a little bit, but edge is not good for every species. So obviously you can't turn to your neighbor here, but I want you to think about why edge. We tend to talk about edge like it's this great thing, but really edge can be detrimental to some species. And I think this is a good place to stop this first video. So I'm going to stop. I want you to think about why it would be helpful to some and not helpful to others, and then we'll continue on and look at edge in a little bit more detail.